today. Last week, what did we start off talking about?
You don't remember.
Transformation. All right. What was the definition we used for transformation? All right, change. We're changing where this figure we started off with. We're going to change where it's either located or the size of it. All right.
Correct.
From there, what was the first type of transformation we talked about? Translation. What was the word we talked about? And what was the word that I wanted y'all to think about when we saw the word translation? Slide. So in essence, that's kind of what we're doing. So let's go through the definition of the word translation. Translation is what?
It's a change made to the location.
A transformation, right? That's what it starts off. Is that what it says?
Yeah, transformation.
All right, so a change in the location or size of what?
Where each point is.
Where each point. All right, now, what do we know about a point on a coordinate plane?
As an X and Y.
As an X and a Y. So that means that, keep reading, we're going to have the change in the location or size where each X and Y coordinate does what?
Is moved in the same direction.
It's going to move in the same direction. So all X's are going to move in the same direction. All Y's are going to move in the same direction. What else?
And same distance.
All right, so the X's are going to move in the same distance, and the Y's are going to move in the same distance. All right? Does that make a little bit more sense now? So wherever the first X goes, when we move it, all the other X's are going to move in the exact same way.
Correct.
And what?
And
Distance. However far it's going to go, and whatever direction it's going to go. So now we got these points that we did some type of transformation to, and now we got this whole new picture, this new figure. What do we call that new figure?
Reflection.
Huh?
Reflection. The
Not even up
image.
there. Huh?
Image.
It's the image. That's what the new figure is. And so now we got this new figure. We can't just keep using the regular points, A, B, C, D. They got a whole new name. What's the whole new name?
The prime.
We use the prime. All right. So we got A prime, B prime. That says, oh, check this out. This is the new measure. This is the new image. This is the new figure. All right. Cool. So that was the first type of transformation we talked about. Today, second type of transformation, big transformation. What is the second type of big transformation?
Reflection.
Reflection. Cool. What's the definition?
Transformation.
So stop. A change in the location or size of a figure where the figure is what? Reflected. All right. Now, when you think of the word reflection, what automatically pops up in your head?
Mirror.
Mirror. All right. So.
Here we go. Let's start teaching.
Now. All right, now. If I'm looking at a mirror, right, here's my mirror on the wall, whose figures of the mom. And I'm looking in this mirror, and I want to raise my left hand. What ends up happening? Which hand is being raised with mine?
Yeah, right.
So if I'm looking in the mirror.
Oh, you're right. You're looking in the mirrors.
Which hand is over here?
Right.
Oh, okay. What about this? If I raise my right hand, what? So, what happens to my image?
It's the same, bro.
You switch it and flip.
Cool. Reflection. The two words I want you to think of when you talk about reflection. One, mirror. The other one, flip. Which in essence is exactly what's going to happen. The image is either going to be flipped or it's going to show the mirror image, the other side of it, as where we're going. All right? Alright, so I got this figured. A, B, C, D. Alright? We have this thing called the line of reflection. What does it say about the line of reflection?
The line, the figure is reflected over.
So it's one line that we're going to flip, we're going to reflect, we're going to show the mirror side of an image. Now, we're only going to talk about two. It was three, but I don't feel like doing the third one because, you know. So we're going to do two. The first one, we're going to flip it across, we're going to reflect it across the x-axis. Which one is the x-axis? Is the one that's horizontal or the one that's vertical?
Horizontal.
What's that mean?
It goes
Horizontal. All right, so if you can't remember, think about the sun coming over the horizon. Is the horizon up in the air or is it?
Side to side.
It's going from left to right.
What's the third one called?
Y equals X. That's the Y equals X line, but we're not talking about it. Now, we're going to flip it over the x-axis. All right? So because I'm flipping it over x-axis, this is what I want you to do. I want you to think for a second. Something happens to the x and the y coordinates when we reflect it across the x-axis. All right? We're going to flip it across the x-axis. So who can give me a guesstimation, hypothesis? Who can describe what could possibly happen if we flip it across the x-axis?
It would turn upside down.
So what does that mean?
It
What
would
does that
make
mean for
that
the...
same shape, but it would be just.
Okay, so what does that mean for my x and my y coordinates?
There would be.
Okay, stop. Let's do one. If I look at just the x coordinates, what happens with the x coordinate? Is it? Let's look. Think about it. Flip it in your head. Flip it in your head.
The X coordinate. What is it? Whoa.
Oh.
Starts here.
It would be.
Oh, just like the top is
It
on
would
the
be the same
bottom.
number, but it would be negative.
What will?
The
The top will be on the
D
bottom.
and C.
like.
So stop. Let's talk about just the x coordinate.
Which one's that?
It would be the same number, but it would be negative.
It's the first coordinate. It's x. X coordinate. We don't even have to need numbers right now. This is just a broad thinking. That's the first coordinate. Whenever going along the x-axis, that's the x coordinate. So now if I'm flipping it over the x-axis, what happens to the x coordinates?
It's in the opposite spot.
Does it? Let's look.
Smart.
Here's my picture, right?
Yeah.
I want to flip it, reflect it across the x-axis. What happens to the x coordinates?
It changes to the complete opposite.
Does it? So you're saying all the x coordinates are what on this side? Positive. So you're saying they're changing.
Change it to
Negative.
negative.
All x coordinates?
Yes.
No.
Maybe.
Everything along this line right here,
It's positive.
they're going to be positive, right? That's the x-axis, correct?
Correct.
So if I go from here
Just D and
to
C.
here,
Oh, it just stay the same.
D and C.
they stay the same. Why do they stay the same?
Because X
they're
is
not.
like this way. You have to move it side to side for the x-axis.
If I'm lining everything up, each one of these lines represents an x
Yeah,
coordinate.
you have to move it that way to change the x. You have to move it left to right to change that.
So because I'm going from here to here, the x coordinates do not change. So, with that being said, we go from the x coordinate to the what coordinate? Y. So what happens with the y coordinate then?
It changes to negative.
So what's another way of saying that? Because what happens if I start down here, and then I want to flip it across the x, then it goes
It's the
something else?
opposite.
What's another way of saying that? What happens?
It changes.
Changes what though?
The y coordinate. The x coordinate. Point.
Let's change points. It stays the same. It has the same numerical value,
It changes
distance.
whether it's positive or negative.
So what's another word for positive or negative? They are called what? What's another word for symbols? Starts with an S.
Sign.
Shape.
All right. Any questions on this?
Where'd you put sign?
I understand.
Oh, I see where you put it.
It's pretty easy. I don't know. I'm confused.
All right, now we've done the X. We've done X. We're flipping it over there. Boom. I keep writing on this. Now I want to reflect figure ABCD across the y-axis. So which one is the y-axis? Y-axis goes what?
Now,
What's the word for that? It's the V word.
Vertical.
It's vertical. All right. So now, instead of going from here, I'm going from here to here. All right. So now, what happens with the x and y coordinates?
They say
the
that.
x coordinate changes signs and the y coordinate stays the same.
X coordinates change the signs, and the y coordinates stay the same.
Oh, I get it now. Yep.
All right.
Oh man, I read that wrong.
So now let's do this. All right. So now, let's see if this makes sense. We made a suggestion, a hypothesis. We guesstimated. Let's see if it comes true. And use that to see if our picture does exactly what we wanted to do. Now, I want to flip this across the x-axis. The x-axis. So what did we say was going to happen if we reflected across the x-axis?
X stays the same and y changes time.
Cool. So now we're gonna make a new figure. So that means it's gonna be. We're gonna make a what? Gonna draw in. What's another word for new figure that we use?
Image.
The image. And because it's the image, how do we write these points? They are now called, instead of A, B, C, D.
A
that-
prime.
All right.
A prime.
So for A prime, what would be the coordinates for A prime? It'll be 3, -1.
Correct.
Because the only thing that's supposed to be changing is what?
The y.
The y coordinate. Well, what are we changing with the y coordinate?
The
sign.
Change the signs. Yeah.
All right. So here we go. 3, -1. Then we go to B prime. What is it?
7 -9.
7, -1. All right. What else do we go to?
6.
C prime, which
C
is
prime.
what?
6 -7.
Yeah, 6 -7.
6
7.
-7.
6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7. 6 -7.
6 what?
-7. And then D
4
prime.
-7.
So D prime.
And it's 4, -7. Adjusted. Ooh.
Did it fit?
Yes, it did.
We know that. So because it did do what we were hoping it did, we can still say that, hey, if we're flipping it across the x-axis, the x coordinate stays the same. We change the sign on the y. It's gonna keep the same numerical value. We just change the sign. All right. So this one.
Yellow.
All right, now I want to flip it across the y-axis. The y-axis. The y-axis. So because I want to flip it across the y-axis, what has to happen? What are we hoping? What do we do that we hope to get the same result we hope to get?
You want the X
Y
change
stays the
sign?
same and X changes.
Y stays same, X change signs. All right. So starting with A prime. What is my A prime gonna be?
-3, 1.
Wait, we've already got an A prime. So what is the new thing we gotta call it?
A double prime.
A double prime. So what is it? What is the coordinates for A double prime?
-3, 1.
-3, 1.
We're learning.
B double prime is gonna be what?
-7, 1. C is gonna be
So where's C gonna be? Is C gonna be back here?
no.
Where's C gonna be?
Wait, no, it's gonna be
But a
on the
little
left.
over.
It's gonna be. It's gonna be.
No, it's on the other side.
Yeah, that side.
That's C.
That's
This is gonna be C?
yes.
Yeah.
Cause you
Sure.
flip it.
Yeah,
And it's
because
gonna be like
negative
that.
6 over here, and then you go up 7.
And it's on the
Yeah.
same side as B.
Yeah, because -6.
Yeah.
So C double prime is gonna be what?
-6, 7.
And D prime double
It's gonna be
prime?
-4.
But it looks just the same though. How do I know what's the difference between them?
The prime.
The double prime.
Which point is closer to the y-axis? Is it A or B?
A.
A. Which point is closer to the y-axis? D or C?
D.
D. So if I flipped it, here's my thumb on A. When I flip it across the y-axis,
Still gonna be on A.
what should be the closest?
Oh.
A. What should be the furthest?
B.
All right, up here. My thumb's on D.
D.
What should be closer?
D.
What should be furthest?
C.
So it's just like flipping basically.
That's what's the word we're gonna use it.
Alright.
It's just flipping over that side. All right. Now here's the kicker. How can I distinguish between if I'm looking at a picture? How can I tell whether that picture was translated, or I use translation versus I use reflection? How can I tell the difference between the two?
Because.
Translation, it would be the exact same shape on the other side. Because like A would still be the furthest away from the Y if you were doing translation. Just sit across. Reflection, you're flipping the whole shape over.
Say that one. Hold on. Say that again.
Like with translation, it's you're sliding the shape, so it would just slide across and still look like the exact same shape. The A and D would be still on the same side, but with reflection, you flip it. So
Well, A and D still on the
No,
same
but
side?
translation is
Yeah,
like,
like
it moves where it is on the
A
ground.
and D are
So it
closest to the
slides,
Y
so like-
there. When you slide it across, it'll be the furthest from the Y on the other side. And then with reflection, you flip and it still is.
So basically, on translation, you don't flip it, you just slide it. And on reflection, you flip it.
So how can I determine two? So if basically what you're saying, and kind of what you're saying, if this was a translation, this point would be what?
D.
This one would be what?
A,
D,
D,
C.
What if I wanted to translate it down?
It would be
What would happen?
A would be down on the bottom.
So A would be down here. What about that?
B, D,
D,
C.
C.
You're about to see the difference between the two.
Mm-hmm.
Because somebody's going to make that mistake. I'm going to ask you for a translation. You're going to give me a reflection. I'm going to ask for a reflection. Somebody's going to give me a translation. All right. Questions on this so far? Anything I need to clear up real quick?
What's up?
All right, here's another one. All right. There's this thing called the line of symmetry. What does it say that the line of symmetry is?
The line that divides the figure into two parts that are a reflection of each other in the line.
All right, so I got a line. Now this line does what with with this particular figure? It does what?
Divides them.
It shows same.
It makes them into two parts.
But
What does that mean? We did basically you did what with the
Divide,
Well,
split
split
them.
them, but they're the same thing.
What's another word for
You
split?
divide them.
What did I do with this? I got this figure.
Broke it in half.
I put it in, cut it in half, two pieces,
Put it
right?
in two.
Now, I want to see if both of these halves are exactly the same. If both of they are the exact same, then I now have a line of what? Symmetry. So, cut it out. Now here's my quote unquote line of symmetry. Now let's see if it's true. Alright? So, blah blah blah. Now I'm opening it. Does the left side equal the right side?
Yes.
Yeah.
It does.
No. There's slime.
No, because you got the
I'm
top
just talking,
corner.
no, the outer picture, not the inside, everything on the outside.
Yes.
No.
No, because you got it folded over.
It's the
Oh wait,
old-
no, you have it up there, so no.
Oh.
So does it
no.
look the same?
No.
So would this be considered the line of symmetry?
No.
No. Now,
Yes. Now.
Yeah.
would this line right here be considered the line of symmetry?
Yeah.
Yeah.
Yes, because this looks just like this. Now, if you were looking at the smiley face, give me some leeway on my drawing, because my drawing is horrible.
It's
But
not even.
say I had a picture of a flag, all right,
Flag, no, no.
and I cut the flag in half. So,
It wouldn't be.
The United States of America.
No.
no, what's the flag of the
Red, white, and blue, man.
Yeah.
no, fool.
It's white with an X.
The state of Alabama, right? So,
Yeah.
Oh yeah. Smoking hot
Like
oil.
that.
That's not the Alabama state flag.
Yes, it is. I know. It's right on.
all right, so here we go.
Yes, there you go. Man. There you go.
All right, so that's the state of Alabama, give or take the thickness of the lines, right?
Yeah.
Cool. So let's see if this is going to be there, if they have a line of symmetry.
They do.
A little bit, because one's a little bit.
It's
Except he's wrong.
All right, let's see if I can cut. If I go vertical,
vertical. Yep.
Yeah.
Right down the middle. There you
does this side look like this side?
Yeah.
Yeah. Yes, sir.
Okay. What about
go.
this one?
Horizontal.
Yep.
Yes, sir.
Give or take the drawing, because
Yeah.
if it was going straight through the middle,
Yeah.
Yeah.
would the top be the bottom?
Yes.
Okay, cool. What about?
Yeah.
Yeah.
So you're saying if I took this one right here and folded it, that'd be the same?
Yeah.
Yeah.
No.
When you fold it, it would be.
It'd
Because
be
the
kinda
flag's
tilted.
yeah, because it's not a square. I don't think the
It's not
flag.
a perfect square, right? So that diagonal won't work. What about this one?
No. It would be
No.
the same thing.
So, how many lines of symmetry does this have? Just two. All right. Let's see. Trapezoid. Let's see how many lines of symmetry. Does that work?
No.
Nope. What about this one?
Yes.
All right, so
That's the only
can we do any more? What about the diagonals? Does the diagonal work? What about the other one?
No.
No. So how many lines of symmetry
one.
does it have? All
One.
right, cool. What about the triangle? Let's look at the triangle. Let me see one.
No.
Only one.
No, that ain't gonna work.
Nope.
What about here?
Yeah.
Yes.
Trying to make that down.
If it was perfect, you know. All right. Let's see the rhombus. The parallelogram. What if I did this one?
Yeah.
Yeah.
So if I fold it here,
Wait.
would they be the same?
No.
What about that one?
Yes.
No.
Here?
Yes.
Yes.
All right, who says yes? Hands up. Thumbs up,
Most
yes.
likely
Thumb down,
that.
no.
Yeah, because if you fold it, it'd be like a.
Thumbs up, yes. Thumbs down, no. That is,
Yeah.
this diagonal right here will be a line of symmetry.
No, because the corners wouldn't be.
Yeah, that would be. Because if you fold it, if you cut it. Oh, it's kind of like that flag.
Thinking about that.
So here, look, I'm here. Folded it. Would it be?
No.
No.
It'd be like our crispy.
No, it's
Never
half.
mind.
What about this diagonal? That looks like it.
It's the same.
It's the same thing.
They don't have one.
So does this one have any?
Smart.
Yep. All right, finally, square.
Yeah, a lot.
Does that have one?
Yes. Yes.
What about this
Any
one?
way you get it, really.
What about this one?
Yeah.
That one?
Yes, except that little bit
So
line.
how many does it have? 4. I can't do any more. Because that's it. So each one of those is a line of symmetry. So if I cut it, still whatever's on the left side is going to be the same as it's on the right. All right? Any other questions? Anything I need to clear up? Anybody got any questions?
Nope. She's been filming. Wow. 20 something.